Hello students, welcome to the channel. In our continuing series Basics Explained, we take up topics that you're likely to see on the SAT and ACT and go through the basic concepts of those topics. Today, we'll discuss equivalent expressions, an important topic from SAT and ACT math. So let's begin. The first thing that you need to be comfortable with is operations on polynomials. A polynomial is an expression of a certain degree. So for example, here I have a quadratic polynomial and here is a linear polynomial. So I should be able to add, subtract, multiply, and divide any two polynomials. So if I add these, basically I would look at adding like terms. So here 3x squared remains 3x squared. 5x and 2x get added to become 7x. Minus 8 minus 3 becomes minus 11, right? So that's addition. If I were to subtract, then 3x squared remains 3x squared. 5x minus 2x becomes plus 3x, and minus 8 plus 3, because minus of minus 3 would be plus 3, would become minus 5. So this is the subtraction. Multiplication will take a little longer. So when we multiply 3x squared plus 5x minus 8 with 2x minus 3, then I multiply each term of the first with each term of the second. So I get 3 2s are 6x cubed minus 9x squared plus 10x squared minus 15x minus 16x plus 24. Right? So 6x cubed remains 6x cubed minus 9x squared plus 10x squared becomes plus x squared, minus 15 minus 16 becomes minus 31x, and plus 24 remains as it is. So this is the product. Okay, for division, we can simply use the long division method. So 3x squared plus 5x minus 8 is to be divided by 2x minus 3. So the first term that I would take is 3 by 2x, because when I make 3 by 2x, when I multiply that with x, I get 3x squared. So that's the first thing I need to get rid of, the x squared term, right? So I get 3x squared. And I also get 9 by 2x, so I add that here. This is 9 by 2x, and then I change the signs. So this cancels out, and 5 plus 9 by 2 becomes 19 by 2. So I get 19 by 2x, and this minus 8 stays as it is. Now to get 19 by 2x, I would have to add 19 by 4 here, right? Because then that, when multiplied by 2x, will give 19 by 2x. And then I'll also have minus 57 by 4, because 3 into 19 by 4. I change the signs, this cancels, and 57 by 4 minus 8 would be 57 minus 32 by 4, which is 25 by 4. So my remainder finally is 25 by 4, and I can't solve any further. So here, when I divide these two, my quotient is 3 by 2x plus 19 by 4, and my remainder is 25 by 4. Okay, so that's the first kind. So let's do a quick question on polynomial operations. So these are two polynomials, they are subtracted. So x squared y minus 3y squared plus 5xy squared, minus into minus plus x squared y, minus 3xy squared and plus 3y squared, right? Minus 3y squared and plus 3y squared cancels. X squared y plus x squared y, these two become 2x squared y. And 5xy squared minus 3xy squared becomes 2xy squared. So my answer is option C. Okay, the next kind of question will be about different operations and rational expressions. Rational expressions are expressions where you might have polynomials in the numerator as well as the denominator, right? So let's start with adding these two rational expressions. So x plus 3 by 4 plus x minus 7 by x plus 1. I take the LCM of the denominators, which is 4 times x plus 1. So x plus 3 gets multiplied with x plus 1, and 4 gets multiplied with x minus 7, right? So this becomes x squared plus 4x plus 4 plus 4x minus 28 divided by 4 times x plus 1. So I'll write it here. So that becomes x squared plus 8x minus 24. The numerator becomes x squared plus 8x, 4x plus 4x minus 24 divided by 4x plus 4, right? So that's addition. Subtraction is similar, except for the plus, we would use a negative. So that's the same. Okay, multiplication. When we multiply two polynomials, we basically multiply their respective numerators and the respective denominators. So I would multiply x plus 3 with x minus 7, which becomes x squared minus 4x minus 21, and the denominator 4x plus 4. So that's the product. And division with a polynomial is the same as multiplying with its reciprocal, right? So if I have to divide x plus 3 by 4 with x minus 7 by x plus 1, that's the same as multiplying this with the reciprocal of this, which is x plus 1 by x minus 7. And then we just proceed with multiplying the numerators and the denominators respectively. Okay, so let's do a sample question for this. If x is greater than 3, which of the following is equivalent to this expression here? Okay, so we'll look at the denominator first, 1 upon x plus 2 plus 1 upon x plus 3. So I take the LCM, x plus 2 into x plus 3. So x plus 3 comes here and x plus 2 comes here. So 2x plus 5 divided by x squared plus 5x plus 6. This is the denominator. And then my expression is 1 divided by this whole thing, 2x plus 5 divided by x squared plus 5x plus 6. So it would be the reciprocal of that. So that's x squared plus 5x plus 6 divided by 2x plus 5, which is option B. Okay. And then for equivalent expression questions, you have to be, especially on the SAT and ACT, you have to be really comfortable with these three algebraic identities. A plus b whole squared is a squared plus b squared plus 2ab. A minus b whole squared is a squared plus b squared minus 2ab. And a plus b into a minus b is a squared minus b squared. These are used, in fact, not just in equivalent expressions, but these are used in many places when we complete the squares in parabola and circle questions. Otherwise also, these are very important identities, right? So please remember all three. And let's look at a sample question for how they are tested. So they have an expression here, and they are saying which of the following is equivalent to the expression shown above. So when you get a question like this, try and notice a pattern, right? We see that 9a to the power 4 can be written as 3a squared the whole squared. 4b to the power 4 can be written as 2b squared the whole squared. And 12a squared b squared can be written as 2 times 3a squared times 2b squared. Because 2 into 3, 6 into 2, 12, a squared, b squared. So then this expression effectively becomes 3a squared the whole squared plus 2 times 3a squared times 2b squared plus 2b squared the whole squared. So if we take 3a squared as x and 2b squared as y, then this is x squared plus 2xy plus y squared, which is x plus y the whole squared. So x plus y the whole squared would be 3a squared plus 2b squared the whole squared, and that is option A. So that is how you have to manipulate the expression to get the desired result. Right, so these were the basics of equivalent expressions. If you found this video useful, please hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to upload in this series. I've already uploaded videos on linear coordinate geometry basics, some grammar videos also like pronouns and modifiers. So do let me know what other concepts you'd like me to tackle. I'll see you guys soon in a new video. Take care. Bye-bye.